Welcome to another episode of Imagine Studio Unboxed, where we explore Ericsson's latest technological innovations. I'm Bhushan Joshi, Head of Sustainability for Ericsson in North America. And together with Paul Schalliner, our VP of Network Products, we're excited to share our insights on how software solutions can help improve mobile network energy capabilities to meet the growing demands of new mobile experiences and rising user expectations on quality of experience. With the uptake of new services, increased mobile data traffic, and potential increase in network energy consumption, it's time to redefine the best network as high-performing, energy-efficient, and sustainable. Join me as we take a deep dive into this topic and explore how Ericsson's software solutions can enable incremental energy savings. Let's go talk to Paul. Hey, Paul.
Hi, Bhushan.
Thanks so much for joining us today.
Happy to be here.
Great. Let's dive in. So in our last episode, we discussed with Shishika how Ericsson's RAN hardware solutions enable significant savings, network energy savings. Can you share how Ericsson's software solutions can unlock incremental energy savings while maintaining that quality of experience that users desire?
Absolutely. So the first thing is to make sure we have the best hardware, the most efficient energy performing hardware. So having got that, it is about switching those radios off when we're not using them. So think about being at home and switching the electric light off when you leave a room. And so we talk about putting the radio to sleep, and we have different types of sleep modes. So the first one is micro sleep, and think of that as like a power nap for your radio. It's easy to go on and turn the radio on and off very fast, and there's no impact to KPI. The second one is deep sleep. And so deep sleep is you're switching more of the radio off. And like a teenager, like trying to wake up a teenager, it takes a while, a number of seconds, a number of minutes to wake back up. So then you need to figure out when the network needs the capacity of that radio. And so, for example, the radio may be not needed in the middle of the night and on a Tuesday at 1 a.m. or something like that. So how do you figure that out? We use AI/ML techniques to look at the traffic patterns to determine when the best time to switch the radio off is and back on again. And so that's deep sleep. And then another type of sleep that we have is booster carrier sleep. Now, we think of a coverage layer and a capacity layer. You always want to have the coverage layer so you can make a call, but you only need the capacity layer when you have data traffic to send. So then we can disable that capacity layer unless we really need it. So that's another kind of sleep mode.
Great.
And then it's not only the radios that we put to sleep, we also have sleep mode capabilities in the baseband, in our transport products, and our Cloud RAN portfolio.
Great. So, it's clear that all of these different sleep modes allow the network to be on when you need it and deliver the quality of experience that is expected at that given point of time, and also maximize energy savings. So that's really great. I think, so we've talked about how this optimal hardware design and this traffic adaptive software can enable savings from a network energy point of view. But can we leverage this intelligence and take it beyond putting radios to sleep?
Absolutely. We can manage the whole site in an intelligent way. And in fact, we've built a smart, intelligent, sustainable site on the roof just above our studio. And so what does that consist of? We actually have a solar panel generating sustainable energy, right? That solar panel charges batteries, lithium-ion batteries that are charged and discharged. Right. And then the third source of energy is the electric grid. So the job of the smart intelligent site is to pick the right energy source for the right time at the right cost for the maximum amount of energy performance. So first we'd prioritize solar. So during the day you have solar energy and you can use that. The solar panel charges the battery, and then at night when you don't have solar energy, you can use the battery. And then you can also use the grid if you don't have battery power. So then we can manage those sources in an intelligent way. So one example is you can make the site more resilient. So imagine you have a grid outage. You want to maximize the battery usage in the site. So what we do is protect the coverage layer and switch off the capacity layer so the site can last without grid power for the maximum amount of time. The other thing that we can do is as we have excess power in our batteries, we can sell that back to the grid. So it's a kind of demand response approach. And so that is the best approach to managing a site.
Great. And I feel like the site then brings together holistically this energy management strategy on the supply side, but then also on the demand side, and bringing them together allows the site to be energy efficient. It also allows it to be sustainable and provide the quality of experience, again, that users expect from us. So that's great. I think the last question that we had is, so, you need to be able to measure things to be able to manage them. Can you tell us a little bit about what are some of the KPIs that can be used to measure the success of these initiatives?
That's a great question, and actually the subject of a lot of industry debate right now.
Okay.
At the most basic level, it's energy in for data generated. So it's kilowatt hours per gigabyte of data generated. But some people say that that's not sophisticated enough and that we need to deal with the metrics surrounding coverage and quality of experience that we're generating. And there are a number of organizations working on this problem right now, for example, Addis NextG and 3GPP. And so if you think about the challenge is I want to have a dashboard or an easy way of looking at the energy performance of my network. As an operator, I'd like a rack and stack league table of the cell sites in my network, which ones are performing well, which one needs remedy. So a poorly performing site, I need to go and fix the site to improve the energy performance. The next step after that is to automate that. So imagine a network-wide orchestration ability to be able to manage and correct energy performance issues in the whole site, so I can look at the whole network, manage it in a most efficient way, so I have the most sustainable network that I can.
Great. So, I feel like this question about KPIs is something that the industry is proactively working on, which is really great because we need to keep moving this key topic forward. So thank you so much for joining us, Paul, and thank you so much for sharing your insights. Now we'll head over to the Ericsson studio and take a look at some of our solutions in action. Welcome back to the Imagine Studio, where we have Brian Castellano, Technology Manager. Hey, Brian, how are you?
Hi, Bhushan. I'm doing great. And welcome to the Imagine Studio.
Well, it's great to be here, Brian. So in our last episode, Declan walked us through how Ericsson's RAN hardware portfolio and how its optimal design can really enable energy efficiency within networks. So now, can you provide our audience an overview of how Ericsson's RAN software solutions can enable network energy efficiency?
Yes. What we're going to look at is traffic adaptive software, and the first thing we're going to look at is boosted carrier sleep. Let's talk about traffic adaptive software.
Okay.
Which includes sleep mode functions that cater to both low capacity scenarios and high capacity scenarios.
Okay.
And this is to fulfill capacity demands. The new baseband and the radio software will enable sleep modes intelligently without impacting user experience or network KPIs. We'll now look at key features, boosted carrier sleep, which provides operators the ability to overlay carrier aggregation opportunities with sleep mode. What is sleep mode? Or what is carrier sleep mode? This is a feature that automates deep sleep and classifies carriers as either coverage or boosted carriers. By default, the boosted carrier are turned off and only activated during traffic intense hours. This allows for more opportunities for cell sleep and radio deep sleep to be activated autonomously. In short, boosted carrier sleep helps to optimize network performance while conserving energy. Next one that we will look at is AI-powered MIMO sleep. With the introduction of the new AI-powered MIMO sleep, AI algorithms are applied to the baseband to forecast traffic patterns and autonomously apply a reduced MIMO when traffic capacity demands are low. The next one we will look at is massive MIMO sleep. Massive MIMO sleep allows for network-wide energy savings by turning off the antenna branches. This capacity, we may use 16 branches or 64 branches, depending on the amount of capacity that is required. Two modes can be utilized. Performance mode, when we just turn off the transmit branches, and echo mode, when we turn off transmit and receive branches.
So I think the question that we might have is, how does AI and automation help in this process?
I'm glad you asked about the AI. It's a hot topic now. Today, AI and automation are optimizing network performance, enabling energy efficiency, and lowering your carbon footprint. Our AI-powered services provide energy performance, solutions tailored to network demands and deployment options. Ericsson's RApps, Strategy In-Service Management and Orchestration Platform, is to provide intelligent automation, operation, as well as future-proof architecture supporting Open RAN. What you see on the screen is a visual representation of what our RApps can do. RApps, a software application that can be used for RAN automation and optimization to address the complexities that you need to automate what you can, leveraging the analytics to get better insight into what is going on in your network to help you make better decisions using various parameters, using traffic load, energy consumption, and your network's performance. Here's an example of an Energy Cockpit RApp, or what the Energy Cockpit RApp can do. It identifies over-dimensioning scenarios that support network monitoring and visualization and ranking based on the energy consumption. I hope this provides an overview of Ericsson's software solutions that power energy-efficient networks.
Great. Thanks, Brian, for giving us an overview of the RAN software solutions. And thank you all for joining us in this really exciting episode of the Imagine Studio Unboxed. We'll see you soon again in the next episode where we share our insights on how we can redefine the best network to be energy efficient, sustainable, and high performing. Thank you so much.